So I want to end this lesson on how to look for lift with actually looking at some soundings. This is twisterdata.com. It's my favorite site for finding this. You can get soundings from weather balloons, but in most locations, I mean, they're launched at 0 and 12Z, which, at least on the eastern seaboard, that equates to early morning and early evening, which is not the best soaring times. So this is an alternate way to look for soundings is to look at modeled soundings, like actual computer models predicting what soundings will look like. And on this site, there are three models that it has. It's the Rapid Update Cycle, the North American Model, and the Global Forecast System. If you're looking more than 84 hours in advance, that's like 3.5 days, the only option you have is really the GFS. If you're looking within the next few days, the NAM is an option too. They'll usually agree a couple days in advance for the most part, but you can look at the differences anyway. But if it's going to be a nice sunny day, usually the soundings will look similar there. And the Rapid Update Cycle is good for about a day in advance. Not even a day, like if it's the night before and you want to look at the amount of lift. This only goes out to 18 hours on this site, but it has data for every hour. Like, this is hourly resolution, whereas the NAM and the GFS, those are 3 hours apart, the data. So those are the differences there. What you can do in any case, you just click on the model you want and just click on any point and it'll load, and then if you're not happy, you can adjust the point in this little window right here. It will snap to the grid, so it's not going to be exactly where you dropped the pin, but it'll give you the closest point to whatever it has. And then on the left here, you control the hour you want. And it's going to say the time in Zulu on top. To convert that to Eastern Standard Time, where -5 hours in the winter, -4 hours in the summer. So you just have to be aware of that. And the different model runs are up here. It'll default to the latest usually, but if you leave this window open for a while, you might have to refresh and then look and see if there's a later run available. So that's how to navigate through this site. And by the way, once you're on a point, you can switch to a different model and it'll automatically keep the configurations exactly as it was and compare them if you want. That's how to navigate through this data. So this is the GFS sounding predicted for the height of this afternoon, mid-afternoon. It didn't look like it was a great day. By the way, this is an old run that I'm looking at, and it's nighttime now, so that's why I'm speaking of this in past tense, but you'll probably be looking at, this as a tool for predicting, future model soundings. But anyway, yeah, we had a little bit of the temperature profile following the dry adiabat to about, you can kind of estimate the height that these things are at. It gives you the predicted heights. They're going to change with each run. But those are the meters. This column right here, this is the pressure. Yeah, so it looks like, if we follow a moist adiabat, there might be a cumulus base there, but other than that, it doesn't look like there would be any chance of any lift above that. We've got this huge inversion right there. Very, very stable air above that. If we go ahead, tonight we have a big front moving through. It's 12/20 is the date I'm recording this. date before the supposed end of the world. So you can see what a stormy sounding looks like here. This is for 8 a.m., no, actually 7 a.m. tomorrow morning. That's 12 UTC. You can see what this looks like when there's a lot of precipitation. The temperature and dew point environmental profiles will be right on top of each other. That's thick clouds, and it's not always that unstable at the surface. You're not always going to get a dry adiabat unless it's unless you're getting the solar heating. You will get other mechanisms of lift within the clouds, and you can actually use this to predict winds. If you saw my Sandy video, you saw me pulling this image up a couple times. We actually have a high wind warning for tomorrow morning, and it looks like this model is predicting a surface wind of 35 knots, and if you go up a little bit, there's see, that's 70 knots at this level here, 925 millibars. And based on the lapse rate, you can actually predict how gusty it's going to be. Like if you're going to see much higher gusts than that sustained wind, or if it's going to be more of a stiff wind with not much higher gusts. Basically, the steeper the lapse rate, the more prone these higher winds are for turbulent mixing, and those stronger gusts you'll get. Anyway, so that's a stormy sounding. You're hopefully not going to be flying in that, unless you have the experience, of course. Let's go out in front, or out ahead of the front. Well, not really ahead. We're going behind the front, but time-wise, this'll be ahead. Let's see what we can get. Now, behind a cold front, there is sometimes a nice adiabat, a dry adiabat on the surface, and there it is right there. It looks like, actually, yeah, there's going to be quite a bit of lift tomorrow in the late afternoon once the front passes, because this lapse rate will support any minimal solar heating, will cause the parcels to go up to at least that point. And there's the dew point, so humid air, you'll get a cumulus base and probably some nice fair weather cumulus behind the front with lots of lift. Although maybe it's actually pretty windy, so some of the air at the surface may mix. So I'm just getting used to looking at these things. Let's go somewhere else. Let's go somewhere where we know there's going to be a good soaring day. How about Arizona deserts? Remember, we can use this tool to change where we're going. Let's see what we can get here. Okay, this looks pretty high up in the mountains because the surface is way up there. Yeah, this doesn't look like exactly what I wanted. After looking basically everywhere in the usual really nice soaring spots for these perfect soaring soundings to demonstrate, I haven't had any luck in this area of the United States. I don't know if that has to do with this being winter, but basically everywhere I clicked in that region, it seemed like it was just much more stable soundings than I've usually seen around there. I don't know what's going on. I haven't looked into that or anything, but I did find something close to like a perfect soaring day sounding in this area of Texas here, about 150 miles southwest of El Paso. So yeah, that's where I am now, and you can see, I think this is Central Daylight Time there, so this would be 6 a.m. This is 12Z, when they would launch their weather balloon. Again, this is a model, the initialized hour, but this is probably what their sounding would have looked like, and you can see right away the trouble of relying on an actual measured sounding based on a weather balloon sometimes to predict soaring conditions. The morning's a very stable time. This is in the middle of absolutely nowhere, just some deserty kind of area. I actually looked this on Google Maps. You can see El Paso's over there, and this is just kind of like mountainy regions. You can actually tell that based on where this sounding starts. Look, this is the ground, and we're already at about 850 or so millibars. That's the height above sea level. Anyway, yeah, pretty stable here. It doesn't look like you would get any lift from a sounding like this. Remember, these are the dry adiabats, so nothing really, no potential for thermals to really develop. But then if we go 6 hours later into the afternoon, we'll click on this. This is now, I think this would be noon, and look, sun heats the ground, bam, it turns into this. We have a super adiabat there, in other words, a lapse rate greater than the dry adiabatic lapse rate, and that's excellent. That means the surface temperature by itself is going to, if pushed upwards, it's already going to be lift. Said another way, just naturally having a lapse rate like that based on solar heating means you'll get lift basically everywhere. No matter where you are, lift and sink, spontaneous convection in that area of a lapse rate greater than the dry adiabat. And if a parcel's heated a little more, it'll continue to go up. And even some parcels that were just from the spontaneous convection will continue to rise. And notice the dew points there. It would follow a solid mixing ratio line. You're probably not going to get clouds, because even if you get a little bit of a heated parcel, that goes up. We have this block here, so you're not really going to get cloud formation, cumulus formation, visible cumulus, unless you get a heated parcel maybe to there. You would get some kind of cloud development, but you can see the effects of solar heating clearly from this. And then at nighttime again, if we go out a little further, let's go out another 6 hours. Actually, yeah, okay, it's dying down there, you can tell. Let's go out to hour 18 here. Yeah, okay, this is 6 Zulu, so Central Daylight Time this time of year. This would be midnight or so, I think, yeah. Very strong inversion there at the surface. That's actually to be expected because, remember, this is a desert. You get radiational cooling at night. So big contrasts between daytime temperatures and nighttime temperatures. Look at that. That is almost freezing. Let's see what it was during the day. I didn't even look. 10 degrees Celsius. Okay, so it's winter. It's not going to be that hot, but still it's a pretty sharp difference. To Long Island for a second. One other thing I actually forgot to talk about is the wind barbs. I kind of just brushed over that really quickly. Yeah, so that's your temperature dew point profile. This is a typical day over Long Island. These are the winds increasing with height, and first thing to note is the direction. Basically, up is north, this is east, south, west. It's your standard compass, but it's kind of plotted weird because as you go up in height, it's like a dimensional conflict. But yeah, you have to think of it as looking down on each barb from the top, but yet this is going up in height. But I mean, it's still pretty simple. This is just showing the surface wind is from the northwest, and as you're going up, it's becoming more and more west, more straight out of the west with height. And yeah, that's basically what's going on. Now the speeds are, let's see if this can focus in. Yeah, a little barb is 5 knots, a large barb, a long barb there is 10 knots, and a flag is 50 knots. So based on that, you can easily figure these out. That's 5 knots, that's 10 knots, 10, 15, 20, 30, right? 35. Just add all the barbs on the flag. I mean on the stick. 55. Let's see. The flag is 50 plus a long barb is 10 plus small barb is 5, so that's 65. You can see winds get very strong as you go up in the atmosphere, even on a typical day. That's common. You have a jet stream up there, but at the surface it's very light. This is one tool for looking at modeled soundings, or predicted soundings, and it's very user-friendly, and it's at your fingertips if you have internet access. There's another thing you can download to your home computer. It's called BuffKit, and it's a challenge to set up, and it's much less user-friendly, but it's a lot more advanced. So I might do a tutorial on that and setting it up in the future. But for now, this is definitely a good place to start getting used to looking at soundings and predicting soaring conditions for yourself, basically. Alright, hope you enjoyed that.